Good morning, class. This is your instructor. We are going to be studying the second part of the chapter third that we have started, and in the previous lecture we were doing. Let me just help you recall that we were basically discussing about the central tendency and the mean, how to calculate the median and the mode, and then we did subsequently some practice over this. Now we're going to be studying about the variation from the population of individual measurements. So for that we have to consider three things. First is the range, and then the variance, which is actually squared deviation under root, and then that would be the standard deviation. Would be basically the variance would actually be the squared deviation, but when you are taking the under root of variance, you get the standard deviation. But what basically these concepts imply, that we'll be doing one by one. First, we consider what range is. We are also going to be discussing the Chevy-Chev's theorem in this case, because since we are discussing the range of values, basically that is the difference between the maximum value in the data that you have and the minimum value. However, this concept is incomplete without discussing the theorems, the z-score, and the concept of quartiles and the outliers that we have. Now, considering what the range is, if you just go by the let me see, the definition first of all. So we have a population with the mean of mu, and or if you are considering a sample with mean of x bar, and the range is basically the largest measurement minus the smallest measurement. Now what kind of measurement they're talking about? They're talking about the values that would vary from the central part, because we are going to be arranging the data in the ascending order, or you could be arranging it in some order. It could be a descending order as well. It depends upon the requirement of the question. However, usually we would be arranging the data in ascending order, because we want to find out what is the minimum value and the maximum value. And if you look at this graph here, sort of like a histogram, they have given you two service centers in this case. There's an American and the National Service Center, and they take relatively this American Service Center. This center takes relatively fewer days to repair any kind of spare parts or whatever that comes to them, whereas the National Service Center would take usually more days to repair for the same thing. And in this case, we're talking about the computers. So the spare parts could be, for instance, the light bulbs that could be fused in the monitor, for instance. So they could be taking some more time. And then see, this is expanded in this case, because the range is perhaps more, and here it is contracted, or it's compact. So this shows that the range is less. Now how less? So let me just go over the example. First of all, it says that the variation is portrayed by the distribution of 20 repair times in days. So there are a number of days with frequency is in how many computers would come in a particular day, and this width would actually be the class width, and we have already been doing the class intervals, and this basically shows the expansion of the day in both the cases. So because you can't really have, one of the students was concerned that why do we have this block here, So the reason behind is because we cannot just have 1 hour in a day. We can have some time before the day lapses, and this would show that part of the day perhaps, and for how long that particular day would remain. So, and you just make them into equal intervals and equal length as well. So now the repair time for the American Service Center, the times are clustered quite closely. Like I said, that it's compact, whereas that of the national service center is rather, spread farther apart. And the distribution, if they ask you to find out the range in both the cases, that would mean that the number of days that they take, the American Service Center or ASC, I would say, is, perhaps in 5 or within the, average, or it lies somewhat, in the 5th day, going towards the 6th one, or the, 3rd day, which is, either beginning from the, towards the end, beginning towards the end of the 2nd day. So it, spreads from here to, okay, so we'll just pick up from where we left off. So this is the range, and if you want to know the range for the two service centers, so first of all, the American Service Center would consume less days, so the range would be smaller. And in this case, the 5 days minus the 3 days in this case. So the repair time maximum it takes is 5 days, and minimum it takes 3 days. And the range, as you can see, is 2 days, because this is 5 minus 3, and this would be somewhat from 7 to 1, and it's going to be 6 days, I think. So in this case, you can see that it takes max 7 days and minimum 1 day. And associated with this concept is that we need to find out some other variables, some other measurements, and some other units of measurements along with the range, because this does not give us a complete idea, for the reason that all the values are in between. So just considers the maximum and the minimum, but it will not really consider the distribution of the population for a number of days. So if, let's suppose, this the 4th day and here the 4th day, the mean, median, and mode in both the cases is perhaps the same. So that's why you see that the cluster here is the of max value with number of days as 10, and in here it's perhaps since that's the frequency of the number of days with 4 and the frequency as 10, it shows that perhaps the maximum customers arrived and they were satisfied with just the repair in such time frame. If we consider that this time frame would not be sufficient to disseminate the information regarding the distribution of the units in a particular day, that would require us to then find out other measures in central tendency, and one is the population variance and the standard deviation. And if you look at the definitions, basically it's just in terms of the variance, which is the square root of the square of the standard deviation in this case, and when we take the standard deviation, it would be the square root or under root in this case of the variance, which is the sigma square, and sigma is basically the standard deviation. And how you in other words explain the concept is that the population would have various values. Some would be like 2 days, 3 days, 4 days, 5 days. So mean, you could have population mean, and then the values would vary from the mean, so that average number of days perhaps it takes is, let's say in this case, 3 or 4 days, let's say. And but then there will be customers coming on the 2nd day, collecting their laptops or computers, and then there will be others that will be coming and collecting it on the last day. So we need to find out what is the variance in this whole data, so that then we can have an assessment of the accuracy of our measurement, and then we can calculate as you can say along with the value that range gives us. So first of all, in order to find out the standard deviation, you need to find out what is the population mean. And like I said, since the population mean is mu, if we are given a sample, then it will be expressed as x bar, and usually when we will divide for the purpose of finding out the standard deviation, and in this case, okay, so not just a positive square root of the variance, it's also a measure of the variation of the population measurements. And this is on page 109 of your book. You can see here that for sample you'll have n minus 1 instead of n. And if that is the case, then you should bear this in mind. It is because we need to find out an unbiased sample rather than a biased one. So here they've given you another example of Chris's class size this semester. The class sizes are 60. Okay, so this is perhaps one class with 60 students, another class with 41 students, and then another with 15, 30, 34, so on. So calculating the variance and standard deviation of these class sizes, because perhaps either he's it could be a teacher, teaching various classes, or it could be a student, taking various courses where the class size is, varied or different. Now, it's very simple to calculate mu as in the entire population. You can just find out the difference with the help of the, if it's a sample, you'll have less values, and if it's a population, then you can have the entire measurements. And now, you just add them up to find out the mean, and you divide it by the number of values that you have. So in this case, 60, 41, 15, 30, and 34, and then you divide it by the number of observations per class is 1, 2, 3, 4, 5. So when you divide and you add this up, you get 36. So this is your mu in this case now. But now we need to find out the variance as well as the standard deviation. So what do we, do is that from x bar, we can assess what is the, the average dispersion or, deviation of each value x that varies from the mean. And since the first value is, let's say, x, and how much it would, vary, so you can just simply, subtract or take the difference of the, of the first value, and then from the first value you can just subtract the mean, and you get here the 60 minus 36, so you get 24, and then 41 minus 36, and you get 5, and then you have 15 minus 36 as 21, and then okay, so now you see that this number is smaller. Here the x value is smaller than the mean, so it means that some classes would have less than the average size. Perhaps average size is also relevant, it's a relative term in the sense that there could be university rules stating that you can have an average size, or as per our calculation, the average size per class should be like 36. But in this case, if it is less, then you will have a negative value, but you don't have to worry about that, because when you square these values, you remove this negative from here. So now it's minus 2 in this case, 34 minus 36. Now you square these values, so x minus x bar, and now square these values, so 24 square would give you 576, and 5 square will give you 25. Similarly, you have 21. I just treat it as 21 because negative would be, this could be, removed as we square the value, and this is about 441. And then this is 36, and 2 gives you, 2 square would give you 4. Then you just add them up and you divide them again by what we have is now the sum 1082, and by the number of square deviations, which is 5. Now what does this line mean, number of square deviations? Deviation is an English word, okay? So deviation is to, go astray, or just be away from something misguided, in other words, or it's just departing, or it's a measurement that differs from a fixed value, such as the mean in this case, or the acceptable standard. So therefore, it means that we have, every time that we want to find out the deviation, we would, subtract from the main value that we have dispersed, and then subtract the x bar from this mean value. So then we square this deviation, this thing is the deviation, and we square this deviation to avoid the negative signs primarily. And then under root is basically to, actually it also reduces the value size. And because we don't want to have too many a very large value, or too many digits in our results, to avoid having any complexities when we have large you can say calculations. And so see, we have values that we divide with this, and this is a 5, so you get on average 216.4. So now this is the variance. When you just find this out, this is sigma squared, just square deviation, this is the variance. But when we want to find out the standard deviation, what is the standard that we will follow? Just take the under root, and that the positive square root of this variance would be 14.71. So let me just read the theoretical portion of it for you to understand and gain more insight into this. Variance and standard deviation measures the variation or spread of the population measurement, and many measurements will be far from the mean, like I said, and some will be close to the mean. And so many of the deviations from the mean will be small, and the average of the square deviations, the population variance, will be small. Therefore, the more spread out the population measurements, the larger is the population variance. So because the reason is, when there is dispersion or when there is more deviation, naturally the data would vary more. Because for instance, if I say that children with various ages, so now the range is in this case more, because it would be, the higher the range is, and the range cannot be too high, because then it would be very difficult to plot the graph also. And so it's always best to have the under root to give us a compact answer. And with ages reflecting the range from a 5-year-old to a 36-year-old, or it could even be a 50-year-old. So the range could have different values, and the average. So I'm delivering the lecture, sir. So now what we do have is the value which is lying from 5 to 50, and then some or majority of the children could be falling within the age from 30 to 32 or 33. So not only just range, but we need to see how much every child is differing from the mean, or the clustered value is whether close to the mean or is away from the mean. So maximum children lying at what at what distance from the central value. So in this case, this is just the formula as in a general interpretational form. Like I said, that if this is a sample variance, we will be replacing the n with an n minus 1, and that's it. So in this case, you can just simply read up on this, that we have x1 as 30.8, 31.7, 30.1, and 31.6, and 32.1, right? So since the mean here is 31.26, and just simply calculate from the calculator, then you can just subtract every value from this. So you can have from 30.8 minus 31.26, and you can just square this. And similarly, you can square 31.7 minus 31.26, and then 30.1 minus 31.26, and then this is 32.1 minus 31.26. And here you can see this. This can give you, approximately positive value. This can give you positive value, but this cannot give you positive value in the prior to squaring this. But when you square this, the negative sign would be removed. In any case, it will finish. So now, as you can see here, that if it were population, standard deviation or variance, we would be dividing it simply by 5 instead of 5 minus 1. But since it's a sample, so we're just dividing it by 5 minus 1. So we assume that in sample we will have more variation slightly compared to population one, because that data is complete and this is just a portion thereof. And in this case, the deviation would be 0.8, which would be slightly less for the population standard deviation. And because we can say that the sample is not the true representative of the population in this case. So there are other examples that you can just see, and then it's a good thing that they have mentioned another formula, and then you can just take the under root of this, that it is a more general form of the above formula, and then it is another form which is summation x squared, without the even connotations that we have here. If you just remove these symbols even, then just summation x squared minus summation x whole square over n. Now you take 1 n minus 1 outside, but if it was mu in this case, let's suppose the population mean, and then the population standard deviation, so it will be sigma squared, then we will be having this summation x squared over n and minus summation x over n whole square in this case, because then this n would be shifted inside, and then you can just simply divide from, you can just divide the numerator by the denominator and then just take the square of the entire value. And then this is squaring individual observations. So if you have x, let's say, and then you will just square each value of x like we did for the differences here, the deviations. You will just square each value of x and then you just take the sum of that, so you get summation x squared. But here this is just going to be the sum of all x, the values that you have, so you just add up summation x and then you will just square the entire number, okay? And then you just divide it by n square in this case, or you can just simply use the summation x over n whole square, or you can just simply square this separately, or square this separately and just divide. So if you have let's say any value summing up to, let's say, 78, because x1 could be 25 and x2 could be 25, so it's 50, and then it could be again 25, 75, and then 3, so you have 78. So you just add up the x and you can just square this value, and since n we have 5, so you can just divide it by 25 in this case. So you would be getting the same answer, or you just simply divide 78 by 5 and then you square that value. It will give you the same result. Now they have also given a numerical demonstration of this fact, because for sample, since we have n minus 1, so to be sure to remove 1n from here, and then they just add up general values. This is table 2 on page 42. This is just previous chapters. The data would be perhaps in table. Let me just see if I can go to this table. Or perhaps it's not unable to go there without leaving this page. So let's just assume that now we have various values at this time, and the total sum is for summation x, in this case 117. But when we do summation x squared, like I said, this is not summation x whole square, this is summation x squared for this part. So we'll just square individual values of x, and then we are going to be summing this up. So we have this value, and since how many values? They say that the sample was comprising of 65 payments. So we have 65 minus 1. This is a sample, and in the question it will be mentioned to you whether we're taking the sample or we're going for the population in this case. So you just subtract now summation x whole squared. So summation x, this is 1177. So let me just see that if we have a calculator here. Now we have, excuse me, this is, what's the problem with this? Okay, so now let me just see if I can go to that page where it's okay. So this is we have done this in previous lectures. I think I assume this was done in the class, and we have 65 values here, 3, 4, 5, 6, and so there are 3, 4, 5, 6, 7, 8, 9, 10, 60, and 5 values, so we have 65 values. Right, so let's just go to this and go to 3.2. Okay. So now you can just simply, see that this is the 1177. The whole summation x in this case 1177, and into, again, since we're squaring this value, and you get this much, right? So 1385329, and we divide it by 65, and then again by 65, and we get close to about 327. Oh, sorry, 64. We're supposed to be dividing it by 64, not 65 for one value further. So dividing. Okay, we can do that once we solve this. So we got this value as 21312. Let me just do this again for you. Just simply you square this summation x 1177 into 1177, and you get 1385329. Then you just simply divide it by, actually 65 square for population standard deviation, but 65 into 64 for sample standard deviation and variance. So just one time would give you 21312, and this is 22312. See, so 22317, sorry. So 22317, and kind of it gives you 1004.246. Like this is, I'm just going to be removing this number, negative part from the number, and then you can just simply divide it by 64 again. So you have 15.69, right? Either you can just simply, divide it by 64 and then 65 into 64, just take it out common, and you can have this value. Because this value would be, this value would differ from the population in this, that the population variance would be lower than this because you'll be having a higher denominator. In this case, when you take the under root of this 15.69, then you can just, simply take the under root. Where is that? Okay, so now the value we had was 15.69135. And here we have 3.96 days. Okay, so Minitab basically I have not taught you, but I might do so, although it just lies slightly a bit outside of your course outline. But I think it's pertinent for us to also understand the programming part of the quantitative techniques. Now you can see the interpretation. I've already told you about the outliers. Okay, the things which are outside the max and the minimum value, they are usually the outliers. And since we have the mu, this would have the maximum value. It's understood that it's supposed to have the maximum value. And mu plus sigma, and this is mu minus sigma because we'll have a higher value and a negative value. But then now the interpretation, you have to remember these values. 68.26% of the population measurements are within 1 standard deviation of the mean. And 95.44% of the population measurements are within 2 standard deviations of the mean. So you have to remember these percentages: 68.26, 95.44, and 99.73 within the 3 standard deviations of the mean. So this is the tolerance interval, and you can just see that they have discussed this in chapter 6, and the frequency, and we can discuss the details of why we are taking these values in some other chapter, or maybe outside of at least this lecture, because maybe I can individually explain to you, because that is not part of your course. However, you need to just remember that this is 68.26. This table is very important for you to interpret your data, because in the questions maybe some analysis or interpretation is required of you. Then you are to basically understand, even for research purposes, you need to understand this. This is a empirical rule, and let's just see that they say that this is from plus minus of mu within, because we know that the standard deviation cannot have a negative value, because the square root usually does not have a negative value. But what it says that you can subtract from the mean this value, and you can add to the mean this value to give us the max and the minimum points for the interval with the mu. Because what it's trying to tell you is that, in the interpretation is that, since the population is deviant from the mean, so if it is just one time it is deviant, we can just simply add the maximum deviation that the data can have and subtract that same value of standard deviation, and to get the minimum value that can we can get, which can bring us maybe to the other side of the interval. And in this case, it could be the right side, or they can call it the left side from your perspective. It could be the right side. From my perspective, it could be the left side. So, and twice of standard deviation, for some reason that they want to expand this, and the higher we go with the numbers, then you can just have, this value would keep expanding this. But if you find that, this is the bell-shaped curve, and when max value would shift towards, this is perfectly normal curve, and if the values would shift towards one side, or they are going, or tilted towards one side, the positive side, then we can just say that this data is biased or skewed. Skewed basically means that it is turned towards that. Now let's just see that how do we define the tolerance interval. In a general interval that contains a specified percentage of the measurements is called tolerance interval. And I want to explain to you what the interval, basically we want to find out how much the data is deviating from the mean, and we can add max deviations to it. So for instance, if I say that the mean age of the class is students are 20 years of age, And then there could be people who are 19, or there could be someone who's 24 even, then there are repeaters, then there could be, 25 and up, so on. So we want to find out that the standard deviation is basically how much that they can max deviate is by 2 or 3 points by 2 or 3 years. So we can just say that if the mean age was 20, so you can just add, or in this case, our example was till 24, so we can just simply say that this deviation could be +4 and then this deviation could go -4 as well. Then we can find that the range, how much range we can have. And then there could be someone who's outside the range, but then we will be considering those as exceptional cases. Now, you can see this example about the mileage. Now, plus minus S is again for sigma when we had the population measurements, and sample mean when we had the sample measurements as S. We would be having the same, conditions in this case as well, when we have 68.26, 95% and 99.73% of the data. Okay, so now is the Chebyshev's theorem. I believe we have to do this as well. This is mu plus minus k sigma, which is basically is something that you have to memorize at the moment, as we are falling short of time here. That consider any population that has mean, mu, and standard deviation as sigmas. Then for any value of k. So now basically this is another measure that equal. Then this, if we choose a k which is equal to 2. So what is k in this case? It's just we said that this standard deviation is 2 times or 3 times, and this would be the multiplier of the sigma. So in this case, when we have 100, 1 minus 1 over 2 square, there could be 1 minus 1 over 4. So 4 minus 1 is 3 by 4%, or it could be 75%. And then of the population measurements lie in this interval. And then we have 1 minus 1 by 3 square. So this is 9. 9 minus 1 is 8 again. And then 8 by 9 is 88.89% of the population would lie between this interval. But then we could keep on increasing the interval so that this Chebyshev's theorem would not be applicable or feasible for this, because they have already said that this rule is very limited to small range data. We can't have a large base as far as the values of x are concerned, because then the range would be more. The higher we go in the range, it will be impossible to plot this. Just like for instance, they say that this is for 99.73% of the data. We need to have, now k value is the question mark, and we need to find out how much this comes when you calculate this as, so we have 1 minus 1 over k square, and then you can just simply, bring it, just take the under root and just remove the, since this is just 1, you can just simply, isolate this value of k, this is k square. You can just take the LCM, and then you can, this could be k square minus 1 over, and then again you have k square. So either you just take out the k as common, and then you can just simply find out what is the unknown value of this. And they have said that this, when you solve it for k, then it is 19.25. And see that this mu plus minus now 19.25. Here at one point we were saying that this was only 2 sigma, but now we are saying that this is 19.25, which is a lot more. And so sigma, either it has to be extremely small for the value to accommodate a bell curve, otherwise this bell curve would be very much close to the horizontal axis, and would not be possible to have be plotted without mistakes in this case, and not also very precise. This interval will be so long that it will tell us very little about the population measurements and where they lie in this case. So then what we do is we can just simply ignore this if the k or the times that we're taking the standard deviation is very high. for this matter. So Chevy is not very appropriate in this case. Then we come to Z scores, and we want to know about the location of any value, whether it is on the negative side or the positive. We can have a negative Z score and a positive Z score. So in this case, let me just read this out. They just give an idea about the relative location of any value in a population or sample by using the mean and standard deviation. So we do know from standard deviation formula that x minus x bar and then whole square over, n, and then we have a summation here. Or you can just simply have revisit this formula if you just get confused. Here we did this, So we already know from standard deviation formula that we have summation x minus x bar and then whole square. So then we just find out the individual values and you just add them up, and then you just divide it by either n for population or n minus 1. But at least you'll know that in this case we are not going to be dividing it by n, so we have the standard deviation instead. So this is one score. So for instance, this is a company which is giving us a profit margin. So x from the mean. So we can have the mean margin as if you just simply find out what this is, how many values we have. We have basically 5 values, and then just add them up as this is we have 15, and then this is 25. And this is 30 and 42 and then 50. So 50 by 5, just for the second, ignore this percentage sign. So we get 10. So now from each measurement value, we can subtract the mean, and then you can just add these values up. So you'll be having some negative values and some positive values. And then you just divide for each Z score, then you can just simply, in this case, we're not going to be the way we did for the whole summation of every value. You can just simply find out the Z score for each. In this case, the standard deviation is given to us probably in the question, and standard deviation is 3.406, and they've also given you the mean profit margin. We can also find it out from here, and then this is the standard deviation as 3.406. You can just also find out the standard deviation by the method that was mentioned to you before. So then this is minus 2 by 3.406, and you get minus 0.59. So this is, in this case, the Z score for each value. Okay. You can also have the Z score for all the values, mean, the total Z score, but usually you can find it for individual values. And the coefficient of variation, okay, we will just do it in, more in detail when the questions come. But in this case, you can see that this is just a formula that you have to memorize, and it's standard deviation. And this was just x minus x bar over standard deviation. This is standard deviation over mean, and it's just into the, converting it with, in terms of percentages, then expressing it in percentage, multiplied with 100. And you can just simply use the same data. We had 10 here, and then we had the standard deviation as 3.406. Okay, so where is the calculator? 3.406 by mean. And I think we had, and so this is 34% because we multiplied with 100, and this 34. So when you interpret this, you say that 34% of the, this is the varying coefficient by which we can express how much percentage the population value or sample value can differ from in the terms of percentage from the main central value, or on the curve you can also say that this by 34% they can differ. And you can just read up on this explanation. It's just giving you some other examples, and then we have the questions here. And let's just say that we have this question considering the population, you just to calculate what is the range, variance, and standard deviation of the population. Okay, so if I can just simply have this converted into the board right now. Okay, so now we have values as 5, 8, 5, 8, 10, 12, and 15. Okay, so now as you can see that we can just simply, these are the values of x. It's just 1, 2, 3, 4, and 5, and this is these are the numbers, and this is the value of x. We just sum this x as, so we have 15, and then 25, and then 35, 37, and this is 42, and then we have again 50, sum as 50. Then we can also have, this is summation x. We can also square this value, okay? So for future references, let me also have my calculator. I just simply calculate from my mobile, I think. So now as you can see that, okay, so we have summation x squared as, or we can just maybe simply write it down here. Summation x whole square would be 2500. Okay. Now we can just square these individual values. You can find out through different formulas, but now we can also find out the mean in this case. So this could be the whether it's a sample or population. They have given us that population. So we just have sigma, and then we have mu. So mu in this case would be 50 divided by how many values we have? 5. So now we can have as 10. Then we can find out either through the formula method that if it is a formula method, you just simply take the squares, 64, 100, and then you have 144. But let me just confirm this 144, and then we have 15, and you get 225. And then since we can just have addition of all these values, or we can just simply add them up, that's 25. And you get 558. Okay. So now, if in terms of finding out the individual values, so let's just make another table here. And you can have x minus mu. So since our mu is, so let me just write 5 minus 10 comes to minus 5. Okay. And then we can also have x minus mu squared. Right. So now this is for x. This is column 1, and this is 2, and this is 3, and this is 4. You can just simply number your columns, and we're going to be finding out the mean from column, by subtracting the mean from each individual values of x. So now this is 8 minus 10, and you get minus 2. Now notice that this is the central value, this is 0. Now you have 2, and you have 5. But even if you sum this, this would give you 0, because the summation of all values usually ends up in a 0. So we square this, because we won't be able to find an answer by just simply summing these values. So you have 25, you have 4, this will just be 0 again, this is 4, and this is 25. Now how much is that? So you have 50 and 8, this comes to about 58. So this is summation, and I is going from 1 to n, and the summation x minus mu whole square over n. And n in this case would be 5, because this is not sample. Had it been sample, we would just be dividing it by 4. So we have 58 by 5, right? So this would be approx 58 by 5, 11.6. Okay. So this is, right now, since we have just squared this observation, this is sort of like our variance, and when we take the under root of this, and you can simply take the under root of this value, and you get 3.40. So the sigma in this case would be, this is actually equal to sigma square, and this would be 3.4058. Okay, and if you're doing the other formula, then you just simply write it as, just let me draw the line here. Summation x square, this is just individual summation x square over n minus summation x over n whole square, and then this would be under root, because this is the value of one thing. Now let me just see whether our answers can match from both the ways. So this is, what was the value that we had? Summation x square, 558 by, 5 and minus, so summation x in this case was 50, and 50 by, again, 5 whole square, right? So now you can just simply find out, then this is how much is 558 by 5, and you get 111.6, 6 minus, this is 50 into 50 by, or just simply 50 by 5 whole square is 100, which is 25, 100 by 25, and you get 100. As you can see that this is 111.6 minus 100, and it gives you 11.6 under root. So just simply, again, when you apply the under root value of 11.6, it gives you 3.4058. So whichever method that you adopt, it's going to be giving you the same answer. Okay, we have to go ahead with other questions, but prior to that, because there's just this large data, I would assume that you can just do it on your own with the same values of x and x bar. The method employed would be the same. And what have they asked you in this is that given calculate the range variance, and okay, so in this case our range was from 15, and so range, we have already found out the standard deviation, we have the variance, and the range would be from 15 max to minimum value, and we have 10 as a range. Okay, let's just move on to the next question. This, by the way, was question 3.19. Okay, let's just turn on the book now. Okay. Okay, this is the concerning again the same topic. I expect that you can calculate the range, variance, and standard deviation of 10 valuations here. This is x, and this is for which value now of the revenues, given the concerning valuation, the revenues as on this. So this is the revenues, this is probably our target, and simplify it for the revenue. In this case, we have already the discussed the implications when we consider revenue, and since they have, you have to be very careful about what is being asked of you in the exam. For your ease, I have given some solutions to questions so that you can take them as lead for other questions. Let's just move on, because I have to move on to the other section, which is about quartiles and percentiles. Then we can just in lump sum consider some of the solutions. This is again, we have percentile. Okay, so there's an approach which is box and whiskers approach, and this is something which is optional for you to understand. I would advise that you read up on it. Okay, let me just okay. So now we have percentile and quartiles. Simply, percentile is not a percentage, okay? It is the percentage which is multiplied by the number of values, which is n, in short. So if they say that n quartile is linked with percentile, it's very simple. If they ask you about, what is the 10th percentile, usually we'll have to do 3 to 4 kind of percentiles. We have the 10th percentile, the 25th percentile, the 75th, 50th percentile is usually known as the median. And you can just read up on the details. And the pth percentile is the general form of all the percentiles, and it just explains to you the range in which your result would lie. That means that either your result would be lying, below the percentage of the. So if your percentile comes to about 60%, it means that perhaps you are above 60% of the population. Just like in USMLE scores, in the when they grade the medical students, and that some people say that they have got mistakenly, they say that it's 98%, and you have to be very careful in reporting your figures, because this is not percentage, this would be percentile. So it would mean that you are basically above the 98% of the population, and you lie within the 2% range. So this would be 1 minus 0.98 in this case, because 100 minus 98, in other words. So this is P, this is 100 minus P. So this is that percent of the measurements which either fall at or below the value. So you could be above this value, so you will be lying in the 2% range, if you can grasp this concept. Take another example of maybe the accident ratio that can happen. So any kind of percentage can be converted into percentile by the number of values that exist. So if you look at this, the general form, then we have an example which is very important for you. In this, they illustrate that there's an income situation of various households, and how many households they have given us. So 1, 2, 3, 4, 5, 6, 12 households. So we have n equal to 12. Okay, to be very careful that they have placed this comma and the digits ahead of it. There's a space. So this is basically one digit. Okay, so this is 49,312, and there will be 7,524. So these are basically incomes that have been reported for various households, and we want to find out the percentile, which would mean that how many households would be belonging to our range of income or falling below it, and then we would be either above it and the remaining portion of it. So the 10th percentile would be just 10 by 100 into the n value in this case, right? So you get 1.2. But now they say that since it's this I is basically the it's not an integer. It's step 3 states that it's not an integer because this is a decimal value. You need to have an integer which would be a rounded off value. So since it is 1.2, usually go ahead with one more digit. So this would complete it as 2. So read it up as to you round it up to 2. Okay, read it as 2 instead of 1.2. We don't want to have any decimal values. And then so 2 basically means that for the 10 percentile, we can have that our income, we have 2 households, roughly with income bracket of out of the 12, 11,070. So for the next, we have 25th percentile, perhaps again 25,100 into 12. Now this is in itself the whole value. Okay. In this case, okay guys, do remember that in the question it would be probably asked of you as find out the index. So be very aware of the symbology here. This I is representing not an integer but it's an index value. Now 3 would again represent that this is again going to 18 to 1. However, we would take when it comes to the whole digit, we would take an average of the next household and the previous household. So third is this household, but we would again take another household, which is the 4th value, and then divide it by 2. So you're going to be adding this value and this value. So it's going to be 18,211 plus 26,817 divided by 2 to report the average of the income. So in this case, this is going to be 22,514. So because we already said that we try to round up in case of decimal, and in case of whole numbers, we're going to be just taking 1 up anyway. So in this case, we're not going to be for a decimal, we won't be taking the average, but for the whole number, we will be taking the average, and we get this value is 22,514. Similarly, repeat it for 58th and 75th percentile, and this 90th percentile. Now, I think they have made a mistake in one of the calculations here. This is the 50th percentile. So this is the 6th household. You can just make correction here in this data. So this is 3, 4, 5, and 6. So you're supposed to have an average of 41,286 and 49,312. So we have 41,286, 48,216, and 49,312. And then you divide it by 2, and you close, you get 48,764. So just remember this. This is 48,764. And this is not 22,514. So this is just a typo. I think it's just a misprint. Probably they just copy pasted it. It's just an error. Okay. Now you find out 75th percentile. That is correct against the 9th value. Now how you go interpret this? So now we have 3, 4, 5, 6, 7, 8, 9. So this is 72 and added with 90,416. And you divide it by 2 again. So this is divided by 2, you get 81,615. So this is the value of income in dollars that you usually have, and this is the population. 75% of the population would be probably below this, and you would be in the upper range, and then your income would be lying with, if you are within the 75% percentile range. So your income would be approximately this much. And then you have the 90th percentile. Again, this is a decimal. You take the 11th value, which is 135,540 in this case. 11th value is 6, 7, 8, 9, 10, 11. 135,540 in this case. You're not going to be adding or taking the mean of the two values in this case. Now the quartile is the 25th percentile. As in quarter of a century, you say it's 25 years. Then you have the median, which is the 50th percentile, which is lying between the first quartile and the third and fourth one. Okay, so this is first, second, added together is 50th, and then third and fourth. So usually there's an interquartile range which is from Q3 and Q1. So you basically subtract Q3, you subtract Q1 from Q3. And then you have 5 states, 5-step diagram here. That will give you the lowest value. For instance, this lowest value is known as a 5-step graph or diagram, or 5-number summary, you can say. How do you find out? This is just simply this lowest value. Then you can take the quartile 1 that we've already calculated above, quartile 3, and there is a median. See here, they have reported a different median here, and they reported a different median over there because that was a mistake. So usually you have 5, and this is the highest value that you had. Okay, so where's the highest value? This is the highest value. This is the lowest value and the highest value and the median, and then we have the first quartile and third quartile. So you have 5-number summary. And the box and whiskers. Okay, so this is again another. I just want to tell you that there's some misprint in this value 7.25 in finding out the quartile, because they have used a software Minitab that we'll be discussing maybe in the next lecture, or probably some other stage, if it's possible to give you individual time, and then we can just discuss Minitab. Now the value that it gives is 7.25 for the quartile, but if you see that we have 20 observations here, okay, and we want to find out, so the mean, first of all, of these. They have just taken the mean. You can just simply find out the mean by just 10 into 4, and then this is 9 into 5, because the frequency is 5, and then you just simply multiply each figure with the frequency it has. This is 8 into 6, 9 into 5, 10 into 4, and then 7, 5 into 2, and then 3 plus 1. So 1 plus 3 plus 5 into 2 plus 7 plus 8 into 6 plus 9 into 5 plus 10 into 4. So this is very easy. You can even do it on your mobile or on your calculator. So now what have they asked? Okay, so the mean comes to about 7.7. This is very easy for you. Just simply do as I have said. The mean is correct in this case, and if you want that, I can just simply calculate this for you. Just show you as a demonstration. The simple calculator that we have, or I can just maybe use the same calculator that I had. Can't I minimize this somewhat? Okay. Yes. So now you see that this is 1 plus 3 plus 25. Oh, sorry. Plus 10. Plus 5 into 2. And then plus 7. And then plus 8 into. So how many? 3, 4, 5, 6. 48. So 8 into 6. I don't know if this is giving you the correct answer. No, let's just plus, this is 3, 4, 5 plus 45 plus 10 into 4 is 40, and divided by 20 observations, because it does not give you the correct value, because I think you have to simply just do it separately. So 1 plus 3 plus 10, you just simply separately multiply this, because it's not visible when we multiply the numbers. So just simply do it separately. 10 plus 7 plus 8 into 6 is 48. It's 48. Yes, plus this is 45 plus 40. So see, this is 154. Now you just divide it by 20 and you get the value as 7.7. So this is the mean. But when it comes to the quartile 1, now quartile is basically 25 or 0.25, because this is 25 by 100 into 20. So now it's 0.25 into 20, and you get 5. So now the value of the percentile is 25, and 25 is the first quartile. So now just see that this is 1, 2, 3, 4, 5. Okay, so now 5 is falling at the value 7 here. And as I said, that we are taking the whole numbers as the average of the next number and the previous number, right? So the fifth value is falling at 7, so we take the next value as well. So 7 plus 8, and then you just divide it by 2, and you get 7.5. So the mini-tab is basically employing another approach in which it perhaps deletes certain outputs, and then it's just giving you a lower value. And we have a higher value of quartile 7.5, so we're just going to be working with that. And I've also put that in the solution part for you. Why is it different? Because it's just one problem that needed some explanation. So this is 7.5. In this case, similarly, the median is 8 for 50th quartile. So when they talk about median, you just simply multiply 50 by 100 and then just multiply it with the number of values that you have. So this is 0.5 into 20. So now this is 10. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 as 8. So now again we have 8 plus 8, 16 by 2. So you get as 8. And just to check another, we have quartile 3 in order to find out the interquartile range, which is again 75, so it's going to be 0.75 into 20, and you have 15th value, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, this is the 9th value, so we have 9 plus 9 as 18, okay? So now just divide 18 by 2, so obviously you get 9, right? So this is correct, this is correct, but this is just slight, inaccuracy in this. Now let's just go down a bit. What they're doing here is, okay. So they have just simply explained to you that this is the interquartile range, and this is the quartile line, this is the median, and for any value, median is the central part here, and the 50th quartile, since either the values would be lying here or towards the right side. So this is either adding from quartile 3, and then we have subtracting from quartile 1. Because we are to find out the interquartile range, and like I said, it's quartile 3 minus quartile 1 to find out the which is lying in between the two quartiles, the range. So then there is a formula that you have to remember, that for first part we find out the interquartile range value first, and in this case our interquartile range value should be from 9 to 7.5, so it's 1.5. So this 1.5 will be multiplied with 1.5, and then you can just simply subtract it from 7.5. So you have, in this case, they have just given you a slightly raised number because of 7.25, but this is, in our case, going to be 1.5. So multiplying both, and then you subtract from the quartile 1 to, this part will be subtracted from the first quartile, and this would be subtracted from the other quartile. These are known as the whiskers, the plot whiskering. This is or simply the whiskers, it's the dashed lines, okay? Because one value could be, is 4.625 in this case, and this is just 11. That's the upper limit. So this one limit would be, more or higher than the other limit. So it's, whiskers is basically, on a person's face, it's just sides. So when you say the plot's whiskers, it's just what are the, towards the either ends of the median, how far that, you can simply just, this is just the ratio that they have calculated as, how many times that you can, get the interquartile difference, and then you just simply have to remember this part, and then we can maybe find out what the, satisfaction ratings in this case are for 20 values. So now basically now these side limbs basically, they just tell you about the smallest measurements, and then we have the upper limit in this case. And they are also known as the outliers. Now the purpose for this is that we want to find out what values exist outside of the median, towards the lower end or towards the upper limit, which are going towards the upper limit, maybe more than the third quartile and going towards the fourth quartile in this case. So then we can, especially for reporting results, like SAT, GMAT, or GRE. So you can, look at this. It's just a box in which they have just constructed, having, simply ratings. I guess this is satisfaction is another case. I just go through ahead with this. We'll just go over to the questions quickly. I have, since there's, not sufficient time, just simply I've given you a few of the solutions here. Let me just see if I can. I've saved them for you and I'll be sending them to you. Okay, let me just go over them. I'll be just minimizing this so that you can see. Oh, contour simply. Now again, I can just discuss a few questions that I've already, the ones that needed some verbal explanation. You can just simply go ahead and with the explanation. This question I've already solved for you. You can just look at it again. I'm not going to be, repeating the standard deviation and z-scores. You can just go ahead with examples. What I really need for you to understand is the question 3.28 and okay, so these that I've already discussed. So I think it's just tell how many questions are. All right. So basically, this question says that you have to explain the following in your own words: the percentile, the quartile, and the interquartile range. So here you can just simply say that the values that are below 25% or above 75% or below 75% is just measurement, and whether you're trying to explain the lower half of the population, that most values would lie within this region, and yours probably would be, you're probably above all these values that are below. And then you have the interquartile range here. They've just simply asked you to explain that. We would be doing the numericals in the next phase. Okay, just consider this example 3.23. This question is in the previous section. Let me just go back to the previous section. And so we here have 3.19, 2, and 3.2, A, B, C, D. Okay, it's just a matter of interpretation. And do we have 3.22? Okay. Well, basically they're just the same. Just 3.23. Okay. Just quickly, where's 3.23? Now the mean and standard deviation of 40 trash bag breaking strengths are, mean and standard deviation of the sample, you can automatically understand. The histogram of where the empirical rule should be used to describe the trash bag breaking strengths. This requires more analysis, and you can just simply find that the histogram, as we've done before, that it just gives you, detail about the distribution. You can also calculate the range of the values, but since we don't have the individual x values, you can just simply see the symmetry lying within the mean range, and they are normally distributed, and empirical rule is appropriate in this case because we can see that standard deviation in this case is very low. So we would assume that the the k value would not be very high in this case. So now the B part says that using the empirical rule to calculate estimates of tolerance intervals, cutting 68.26%, 68, 94, and 99.7. So first of all, let me just take you to those values where we started this 68.26. Okay. So where we did all the, this is for instance 68.26 for standard deviations is example 3.8, and we just have x bar plus minus s. So you can just simply put this formula, and then you can just estimate that this is either the, when you subtract it and when you add it. So you get two values. One is the upper limit and the other is the lower limit. And we estimate that 68% of all individuals will obtain mileage between this. Okay, for 2s and then for 3s, you can just simply interpret the data in the same fashion. What was the x bar plus minus s? And so this is x bar plus minus s, so 50.575 plus minus s 1.6438. So you can see that this is plus minus 1.6, so this is the lower limit when you subtract and when you add it up. And then you can just simply explain that 68% would lie within these values, 95 would lie within these. When you multiply it each with, when you subtract and when you add, you just multiply it with 2 sigma. So first of all, you're going to be multiplying the s with 2, the number that you get, and then you can just simply subtract this from 50.575 and add it up. Then you can find the upper and lower limits, and then you can just repeat the whole procedure for 3s as well. Then C part is again in analytical, then just explaining that 99.73 that we've calculated here, that if a number of the sales force submits okay, so if a member of the sales force submits an entertainment expense of 190, should this expense be considered unusually high? Okay, so now you have to see what is the range at 99.73, which is the third S. In this case, this is 45 to 55. So see, this is the maximum the trash bags are between this. And okay, now is it the same question? Oh no, that is not the same question. Sorry, this is part C. Yes. Again, similar, I think they've asked us about the tolerance interval, that does the estimate of tolerance intervals containing 99.73% of all breaking strengths provide evidence that almost any bag a customer might purchase will have a breaking strength that exceeds 45 pounds. So now again, you have to consider what was the value at 99.73, and we have calculated that as, again, x bar plus minus 3s, and this was between 45.6 to 55.5, and this is lying between, this is towards the lower side, and its breaking strength is lower and this tolerance level is lower. So you can just simply say that, we'll have a breaking strength that exceeds pounds, let alone 45 pounds. So what they have mentioned is way lower than, than if we have a trash bag, let's suppose, we have breaking strength that exceeds 45 pounds, and that is all the bags would be going with that range, because our lowest range is starting from 45.6. Okay, and now the D part again, the same, the values that we had for tolerance level, or the strength that we need to find these intervals for. What they're asking is that the percentage of the 40 breaking strengths, okay, in table 1.9, I hope I can just reach 1.9, because this is I think chapter 1. Okay, we have done this. So waiting times, yes, we have done this. You can just go over. So now what they're saying is, so you can just simply go back to this table. And now let me just go. Oh. So now the last part is simply saying that, how do the percentages of the 40 breaking strengths that actually fall into the intervals compared to those given by the empirical rule. Now if you see that you have to find out, take the data and you just, for each individual value, you can just simply calculate how many out of 40 would actually fall within the, this first range as 68.26. You can see this interval is from 48 to 52, but our last is, is from 45 to 55. So this part would actually, ask us to, calculate with the intervals of when this is 68, this is 67, automatically you can find out this is 68, sorry, this is around about 95, and then that is 99.7. Then just simply take out how many of those total 40 values given in that table you can have which actually fall in this interval. What was this interval? Between 48.9 and 52.2. So all those values that are lying between 48.9 and 52.2, you will take all those values and then divided by the total n that you have number of observations. So you don't have to take the value of those values. So for instance, if there are 40 values, you can just simply count as to how many values would lie between 48.9 and 52.2. So this part is analytical. So you in the table just count. So you will know that 27 of those values would be from 48 to 52 tensile strength in pounds. Okay, and then you can just do the same process for how many are lying between 47 to 53, because you see now this is overlying and these intervals have overlap. So you'll have repetition of values. So 27, these could be lying in this range as well, because if something is between 48.9, then it could also be between 47 to 52. So this would only be different in terms of how many are from 52 to 53. They would be added up along with 27, so you have 38. And then you have 40 out of, with this interval, because the range is entire values of the, entire values of x. So this will have 100% of the population in this case. So this is sort of an assignment for you. You can just simply come back to me. And if you do not understand how to check the table, then you can always, contact me. And the number which is given to you in Google Classroom. And thank you very much.